Okay, in assignment number 11, we're going to be still solving logarithmic equations, but we're going to be doing natural log equations. And so, as we go through this, remember natural logs are not log, but ln equations. And the base isn't like 10 or something else. The base is e. And so, let's go ahead and get started here with our first problem. We're going to simplify the following expression. And so the properties that we had learned with logarithms still hold for natural logarithms. So for in other words, when I have here the base is e for both of these, bases are the same. I could put the first natural log as the natural log of 2 to the 5th power. If I move this 5 on top, minus the natural log of 4. Well, 2 to the 5th power I know is 32, so I could say this is the natural log of 32 minus the natural log of 4. And so then, because I'm subtracting here, I know that I can take the natural log of 32 over 4. And 32 divided by 4, we know is 8. So it's the natural log of 8. Let's take a look at, I probably shouldn't have done that right here. Well, anyway, so this is the natural log of 8 here. Let's take a look at the second equation here. And I'm going to erase what we have already here so that we have some room to work. All right, so now let's take a look at this problem. We have the natural log, or 3 times the natural log of x. I can put this 3 out as an exponent with the x. And so then I can see this is going to be the natural log of x to the 3rd times y. And the reason I'm multiplying them is because I'm adding those natural logs together. Third situation here, we have the 4th root of both of these. And so I could start with the natural log of 3 to the 1/4 power, or I could just say it's the 4th root of x, plus the natural log of, I could say x to the 1/4 power, or the 4th root of x. But because I'm adding, then I can write this as a single logarithm and say it's the natural log of the 4th root of 3x. And so you can see, first of all, that those properties of logarithms apply in this situation with natural logarithms. So how do we solve an exponential function that has an e as the base? So I'm going to start by subtracting 7.2 from both sides. So we will have e to the 2x over 5th power equals 9.1 minus the 7.2, which is 1.9. And then I want to take the natural log of both sides. The base here is e, so I'm going to take the natural log of this side and the natural log of this side. Well, the natural log of e, because the base is e, natural log of e to the e power, just this is 1. If I move the 2x minus 2x over 5 out in front, that means this whole thing is just going to simplify to 2x over 5. And that's going to equal the natural log of 1.9. So then I'm going to evaluate the natural log of 1.9, which is 0.642. And so that'll equal 2x over 5. So then I'm going to get rid of the 5. I'll multiply both sides by 5, and I'll end up with 2x equals 0.642 times 5, which is 3.2, or close to 3.2. Then if I divide everything by 2, it'll be 1.6. So x equals 1.6. And it's not exactly that, but it's really close. So if I were to stick 1.6 in for this x and take e to the 2 times 1.6 over 5 power plus 7.2, I should get 7.1. Let's take a look at example number 5 then. So this is not an exponential function, but a logarithmic equation, a natural log equation. Remember, the base here is e. So what I'm going to do is I'm going to take e to the fourth power equals this whole thing here. I'm going to have e to the fourth power equals 3x plus 5 squared. So I could have also done this by taking this 2 and putting it out in front and dividing both sides by 2 so that I would have e to the second power equals 3x plus 5. But let's go ahead and continue like this. We have e to the fourth power with 54.6. And then if I take 3x plus 5 and square it, I'll have 9x squared. I'll have two 15x's, which is going to give me 30x plus 25. And I want to get this equal to 0, so I'm going to subtract 54.6 from both sides. So I will have 9x squared plus 30x, oops, and then minus, that's a minus sign there, minus 25 minus 54.6, which is 29.6, and that equals 0. So now I have a quadratic equation, and I'm going to want to solve this quadratic equation so I can use the quadratic formula. So I'm going to have negative b, which is negative 30, plus or minus the square root of b squared, which is 900, minus 4 times a, which is 9, times c, which is negative 29.6, all over 2 times a, which is 18. So inside the square root sign, we're going to have 900. Two negative signs is going to be a positive. And if I take the 29.6 times the 4 times the 9, I'll get 1065.6. And if I take that number and add the 900 to it, we're going to have the square root of 1965.6. If I take the square root of that, we will get 44.3. So it's negative 30 plus or minus 44.3 over 18. So then I'm going to evaluate what those two answers are. So I'll get my two answers, 0.79 and negative 4.13. So if I plug both of those in for x, multiply it by 3, and then add the 5, square it, take the natural log of that, in both situations I should end up with 4, or very, very close to 4, because these are a little bit estimates. So, all right, let's take a look at one more question here. Tyler invested $400 7 years ago in an account that is worth $630.48 right now. If his interest was compounded continuously, what was his interest? Remember, if it's compounded continuously, we're going to be using this equation, y equals the principal times e to the RT. So if we plug in all of our information, we know that it is now worth $630.48. The original principal was $400. We multiply that times e. We don't know the interest rate, but we do know that it was 7 years ago. So we're solving this equation for r. So the first thing we'd want to do is to divide both sides by 400. So this 400 will cancel out, and on the right side of the equation we're going to have e to the, I'm going to put 7r, equals 630.48 divided by 400, which is 1.5762. All right, so then we're going to take the natural log of both sides. So the natural log of e is 1, and if I move the 7r out in front, I'm going to have 7r equals the natural log of 1.5762, which is 0.455. And then I want to get the r by itself, so I'm going to divide both sides by 7. And if I take that 0.455 divided by 7, I get 0.065. So the r, or the rate, is 0.065. And that is 6.5% interest. And so that's the interest that Tyler should be getting in order to have his $400 become $630.48 over a period of 7 years. So these are the type of questions you're going to be doing on your homework assignment. We will go over questions that you have on it tomorrow in class. Good luck, and we'll see you then.